Day 2 of analysis of functions. Today we're going to look at how our calculator can be very helpful for analyzing functions, particularly if the numbers are messy or it's a graph that whose sort of look we don't know. So I'm going to start with x squared plus 6x minus 4, which we know is a parabola, but the specifics of it may not be quite clear. So I put it into y equals, and now I'm going to graph it. In order to do my analysis, I sort of want to see the whole graph. So something is happening down here, so I'm going to go to my window and change my y minimum to, let's say, negative 15, and see if that helps me see it all. It does. Okay, so let's go through our analysis, and I'm just going to say the things out loud rather than switching back and forth. So the domain, right, our x values, we know with a parabola we can use any x value, and we can see that in our graph. It's going from negative infinity to infinity. Our range, our y values, again, we have a graph where both ends are going up, but values down here are not being used. So I sort of need to know what that y value is right here. And I can actually get myself some help using my calculate menu. So the second function of trace, not trace itself, but the second function of trace is calculate. And that point that I was looking at is a minimum value. When I hit calculate a minimum, watch the directions. My calculator says, give me a left bound. So something to the left of what you want. Okay, so I'm going to use my left arrow until I'm definitely, that's definitely left. The question changes to now give me a right bound. It needs to sort of narrow down where it's looking. And now it says make your best guess. Okay, my guess is that it's here. And we're using our left and right arrows and our enter key to find that. As soon as I hit enter, it says that the minimum, it looks like negative 3.000001. When your calculator streams 4 or 5 zeros, it's telling you it's having little pixel issues. That is negative 3, and the y coordinate is negative 13. So I have a minimum at negative 3, negative 13, which is good to know. I'm actually going to write that down. So I have my domain was negative infinity to infinity. I'm currently working on my range, which is something to infinity. I didn't consider zeros yet. Oh, or symmetry. Symmetry. But I do know that I have a minimum point. I'll call it a relative minimum, but it actually is the absolute minimum at the point negative 3, negative 13. Might as well write it down while I'm here. But the interesting thing about that is the y coordinate is negative 13. So the lowest y value that gets used is negative 13. Let's go back to the picture. It did not have any symmetry, but it does have a couple of x-intercepts, a couple of zeros. So let's talk about how we find those. Again, we use our calculate menu, second function of trace, which is calculate. And the function is actually called find a zero. That's to find an x-intercept. It asks me for a left bound, so go left until you are left of the point you want. Okay, so I'm going left. I'm almost there. Okay, now I'm definitely left. I know I'm also above, but I'm definitely left of the point I want. Now it says go right until you're right of it. It's like, okay, now I'm right of the point I want. Now it says make my guess. Okay, that's not a stream of zeros. That's actually real digits. So negative 6.605 dot dot dot, or negative 6.606 approximately, comma 0 is a 0. And now I'm going to find the other one using the same. Second, calculate a 0. It says go left. I am left of this one over here, but I know I'm going right, but I'm gonna go right until I'm closer to it, but still on the left. Okay, I'm definitely left of it right now. And now I'm gonna go right until I pass it. Okay, and there's my guess. Okay, so 0.605 dot 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 or 0.606 approximately, comma 0. So I do have two zeros. I'm not going to remember from there to here, but I do know I had no symmetry, and I did have two zeros. And however I choose to write those. I had a minimum. And I already wrote that down. And since the two ends are going up forever, I do not have a relative maximum. Tell the story. Well, as I'm walking from here to about here, they're decreasing. And then from here going forward, they're increasing now. Hopefully you've noticed that our minimum, like the x coordinate of our minimum, is this value right here. So I will know when I go back to my screen, they were decreasing from negative infinity to negative 3, and then they were increasing from negative 3 to infinity. Okay, we're going to get that into our calculator and take a look. Y equals, clear that one out. It was negative, absolute value is under math number, or it's the first item in your catalog. X squared minus 4, and then plus 3. Okay, I'm going to hit zoom 6 to go back to the standard window. Okay, so there's my graph. It looks a little like Batman, the Dark Knight. Just some of the things that I can tell from here, it is an even function, right? The y-axis is providing some nice symmetry. All the x values along the whole entire x-axis get used. For y values, none of these y values up here are getting used, but they are, since the ends are going down, they are getting used going from negative infinity to something up here. If I could figure out either one of these little peaks here, I could know the y value. So I'm going to calculate a maximum, right? Because they're peaks, not valleys. Go left. Okay, so I'm going to go left until I'm past it. Go right. And then make a guess. Okay, again, my calculator is, I want to point out another pixel issue. When it streams 4 or 5 9s in a row, that's saying that y is 3. It's not really 2.99999. It's actually having pixel issues. It's not a high def screen. So this is a maximum at negative 2, 3. Okay, so I have a relative maximum at negative 2, 3. My domain was from negative infinity to infinity. My range, well, if I have a maximum at negative 2, 3, my range, since it was going from the low values only up as far as 3, would be from negative infinity to 3. My symmetry is, again, it was an even symmetry. I did not look for zeros yet. I have a maximum at 2, 3. Let's take a look at the graph again. Would you agree that because this has symmetry with respect to the y-axis, if I have a maximum at negative 2, 3, I should also have a maximum at 2, 3. Yeah? So I will also have a maximum at 2, 3. And I do have a minimum somewhere. looks like it's right on the y-axis. So let's go and find that. Calculate a minimum. So it says be left of it. Great. Now be right of it. Now go back and guess where it is. It's saying it's at 0, -1. So 0, -1. My zeros, there are 1, 2, 3, 4 of them, but would you agree if I found this one? This is this opposite x, but the same 0 for y, and this I could find. So I only really have to find 2 to know all 4. So second, calculate a 0. I'm going to go all the way left. Okay, that's left of the leftmost one. Now I'm right of that one. And that's my guess. Okay, -2.646 approximately 0. And I will also have positive 2.646, comma 0. Go again, calculate a 0. Be left of it, that's left. Go right of it, that's right. Make my guess at that 0. -1, 0. So I will also have 1 at 1, 0. All right, so I'm not going to go and write those down, but you should write them down. Let's see. To describe this, they are increasing from -infinity until I get to, right, we agree this is -2. They're decreasing from -2 till I get to 0, right? They're increasing from 0 to 2, and then they're decreasing from 2 to infinity. So notice that the x-coordinates of my maximums and minimums tell me something about where I'm changing from increasing to decreasing and vice versa.